This is a quick review of the discrete probability distribution and binomial distribution chapter. State whether the variable is discrete or continuous. A discrete variable is a one that can be countable as whole numbers 1, 2, 3, etc. A continuous one cannot be countable and it can be a decimal. The weight of an employee, of course, it's continuous. State whether the variable is discrete or continuous. The number of computers in the computer lab. You know the numbers could be as low as 0, 1, 2, 3. They can't be decimals, so this is discrete. Number 3, the random variable x represents the number of cellular phones per household in a town of 400. What is the probability of randomly selecting a household that has more than 2 phones? So more than 2 phones, as you can see, it's either 3 or 4. So we need the likelihood of someone having more than 2 phones. It could be 3 or 4. How many have a 3 is 98. How many have 473? You just add them up, and that will give you 171, and divided by the total to get the probability. So that's why you see the answer 171 over 400. Next question. So as you notice, I'm trying to review the chapter using examples and questions. Determine whether the distribution represents a probability distribution. If not, identify any requirements that are not satisfied. For a probability to be a probability distribution, you have to meet 2 conditions. First of all the probabilities in the second column must be between 0 and 1. And then if you add them up, you should get a 1. Well, it looks like they are all between 0 and 1, but let me add them up. If we add them up, what do we get? We get 0.30 plus 0.50, 0.80, 0.90, 0.93, 0.97. Well, 0.97, guys, is not equal to 1, so this is not an example of a discrete probability distribution. Next question. The random variable x represents the number of credit cards that adults have along with a corresponding probability. Find the mean and the standard deviation. I'm going to show you how to find the mean and the standard deviation using Statcrunch for this one. So let me show you how we go about doing this in Statcrunch. So you go to Statcrunch. In one column you enter the values of x. I change the name of the column and call it x. In another one you enter the probabilities, and then you do the following. You go to Stat, Calculators, Custom, Values in x. So you choose the variable x, and the weights, which mean the probabilities, it will be in p of x. P of x, compute. Let me just bring this close. And look, guys, the mean is 1.75, and the standard deviation is 1.125. The mean has another name when it comes to a discrete probability distribution. It's called the expected value. So if you are asked to find the expected value, you find the mean as well. Okay. Next question. The next question has to do with binomial probability distribution. Let me tell you what a binomial experiment means. A binomial experiment is a probability experiment that meets the following conditions. There are 2 outcomes when you do this experiment, either a success or a failure. And the experiment is only repeated a fixed number of times. And the probability of success does not change from one outcome to another. For example, one trial to another. Let me give you an example. If you roll a die 5 times, and you win if you get the number 6. Face up. Let's check if this is a binomial experiment. Well, since you're doing it 5 times, you're doing it a fixed number of times. What's the probability of success? You will win if you get 6, so it's 1 out of 6. What's the probability of failure? Is 5 out of 6. Does this probability change from one roll to another roll it doesn't, then this is a binomial experiment. What are the possible number of successes? It is possible that you roll a die 5 times and don't see 6 at all. So it's possible that you win 0 time, or 1 time, or 2 times, or 3 times, or 4 times, or 5 times. We're going to show you how to do an example with binomial experiment using Statcrunch now. A survey found that 65% of all adults over 60 approve of a retirement bill in a random sample of 10 adults over 60. So the 65% is called the probability of success, P, and the sample of 10 is called N, the sample size. What is the probability that exactly 6 of them approve of the bill? So if you select 10 people at random, what's the likelihood that exactly 6 of them will say that they approve of the bill? Here's how you do it in Statcrunch. I'm gonna close this. You go to Stat, Calculators, Binomial. There you go. N is 10 and P is 0.65. And the question was, what's exactly 6 of them approve of the bill? So we just select equal to 6. And look guys, not only you get the answer 2377, but it highlights the answer. So the probability is 0.2377. Next question. What's the probability that at most 6 of them approve of the bill? At most 6 means 6 or 5 or 4 or 3 or 2 or 1 or 0. And the sign for at most, guys, is less than or equal to. So let me show you how to do that in Statcrunch. All we need to just change the sign as simple as that to less than or equal to. And now you notice it found the probability of x equals 6, 5, 4, 3, 2, 1, 0, added all of them up. The answer is 0.4862. Next question. What is the probability that at least 7 of them approve of the bill? At least 7 means 7 or 8 or 9 or 10. Let me show you how to do that in Statcrunch. Just change that to greater than and make it 7. And you're going to see 7, 8, 9, 10 is going to be shaded. And look. So, and this is the answer 0.5138. Next question. What is the probability that all of them approve of the bill? All of them means if you ask 10 people, all of them say we approve of the retirement bill. So x equals 10. Change 7 to 10 right here. Watch. There you go. It's 0.0134. And let's see what the next question is. What is the mean of the binomial distribution? The mean of the binomial distribution, Statcrunch doesn't do it. There is a formula for it. It's n times p. As I told you guys, this is p 0.65 and this is n10. So just multiply 10 by 0.65 will be 6.5. What is the standard deviation of the binomial distribution? The standard deviation of the binomial distribution is square root of n pq. We know already what p is, 0.65. We know what n is, 10. What is a q? Q is the probability of failure. So if 65% is a probability of success, probability of failure will be 0.35. So your standard deviation, guys, will be square root of 10 times 0.65 times 0.35, and you compute the answer. Okay. Now, I'm gonna create another video and go over the Poisson distribution, very short video.